Hey everyone and welcome. Today we're going to walk you through the process of taking a landscape from World Creator directly into Unity using the World Creator bridge. I'll be using the Biomes of 1 sample, which you can find right in the sample section. Of course, this workflow also applies to any custom terrain you've built. Compared to the stock sample, I've slightly reduced the number of materials and scatter objects here to speed up our import time a bit. Also, an important thing to mention is the restriction in terms of material layers in Unity. Meaning that if you're using the HDRP, keep in mind that it supports a maximum of 8 material layers on a terrain. The universal render pipeline and built-in render pipeline can push past this limit, but be aware that exceeding 4 layers comes at a slightly higher cost to your performance due to it needing multiple passes for the terrain material. Before we hit export, we have one crucial decision left to make: defining the object types for our scatter elements. Let's break down the options. First, we have instance. This exports your element as a point cloud. It's ideal for larger shape-defining objects where exact placement matters along the line of trees or cliffs. The other is detail. This generates an export mask used for procedural scattering inside Unity. You'll want to use this for smaller volume-filling foliage where individual placement isn't critical, like grass patches or small pebbles. Additionally, you'll see the isEntity toggle on instances. Enabling this tells the bridge to place the object as a standard game object in your Unity scene, rather than a Unity landscape object. This is essential for larger interactive elements that need custom scripts, colliders, or specific game logic and should live in the scene. Looking at our current terrain, I've set the trees and larger rocks to instances, while the grass and smaller debris are set to details. With our setup fully optimized, the terrain is ready. We now simply press the sync button in the top right. So, with our sync complete, let's jump over to Unity. Installing the bridge is as straightforward as it gets. Just locate the Unity package from your downloaded zip file and drop it directly into your project browser. Once the import is finished here, you can find the import under the Window menu. Look for World Creator Bridge to open the main control panel. The interface is divided into several tabs to keep your workflow organized. We'll begin our setup in the Terrain tab. First, ensure your XML path is correct. This is vital if you've manually moved your sync directory or changed it in World Creator. Below that, we have the terrain asset name. This acts as a global prefix for every important element. If you're working with multiple terrains in a single scene, using unique prefixes here will prevent assets from being accidentally overwritten during the sync. Next, the Delete Unused Assets toggle is a great way to keep your project clean by removing old materials and textures from previous syncs. However, if you've made manual adjustments to those materials in Unity and want to preserve them, make sure to leave this disabled. By enabling import layers, your World Creator materials are brought in as native paintable layers, giving you the freedom to further refine and blend them directly within the Unity inspector. For performance, we have the split threshold. This determines the size of your individual terrain chunks. Smaller chunks can help with culling and optimization in larger scenes. Finally, ensure your material type matches your project's render pipeline. Whether you're on URP, HDRP, or built-in, this step ensures your landscape material shaders compile correctly. For our project, the default settings are exactly what we need. All that's now left is to hit sync to import our landscape. Now, with our terrain geometry and textures successfully imported, it's time to bring in our scatter data. Let's switch over to the Objects tab. Upon opening this tab, you might see a notice that the GLTF-fast package is missing. This is a vital dependency used to handle the GLB assets exported from World Creator. Simply click the Install button. It only takes a few seconds for Unity to fetch the package and configure your environment. Once installed, you'll see the object import settings. The first is Detail Resolution. This slider controls the precision of your procedurally scattered objects. In our case, the grass and small stones. Higher values mean more precise placement, ensuring your foliage aligns perfectly with the terrain features. Next is Override Prefabs. When enabled, the bridge will refresh and clean your project prefabs every time you sync. This is great for keeping things in sync with World Creator. But if you've manually added components like custom shaders or compilers to those prefabs inside of Unity, you'll want to leave this disabled to preserve your work. We'll stick with the defaults for now and hit sync. In just a few moments, your trees, rocks, and grass will be placed exactly where you designed them in World Creator. Sometimes after the sync, you might notice your objects looking a little off. Maybe they are glowing neon blue or pink, or the shading feels flat. This usually happens because the default GLB import shaders aren't aligned with our terrain's lighting or mesh data. The most robust fix for this is to create our own shader graph. This also allows us to add more advanced features like grass or wind animations, Otherwise, we could also import content from the asset store from creators like Nature Manufacturer or other content creators that already have pre-made nature assets. In our case, we're just going to create a simple shader graph to make the shading look better. We're going to go into the terrains folder, open up our objects prefab folder, and create a new shader subgraph. So we're going to create shader graph, URP, and then select the lit shader graph. We'll now name this world creator opaque for all of our opaque materials like the bark. First, we'll create 3 inputs, one for the color map, one for the normal, and one for the ORM map, which is a packed map that GLB produces, which contains our occlusion, roughness, and metallic. After that, we'll just put the maps into our graph and then create a sample texture to denote after it. Make sure that the normal sampler is set to type normal, since it's a normal map and that's sampled differently. And when we connect all of our different outputs from the ORM map, make sure to invert our green channel, which contains the roughness data, since the smoothness and unity is an inverted roughness. Once that's all done, we can just close up that one. And we'll create a second one for all of our leafy materials. Again, go into shader graph, create a URP lit shader graph. And we'll name this world creator underscore masked. And here the same thing, we'll create 3 different textures. First up a color map, then we'll create a normal map, and lastly our ORM map. So besides that, since this one is going to be a masked material with cutouts, we'll go down here and enable alpha clipping. And we have to set the render face from front to both, so that also the back faces of our leaves are rendered. Now we just drop in our maps again and connect the samplers to our material. This is exactly the same setup as in our opaque material, so I've skipped that part in the video. The thing we now do differently is that we add an invert to our normal map up axis when we're on the back face, so that in that case our normal map works correctly. Lastly, we connect the alpha channel of our color map to the opacity output and set the threshold to 0.1, so we get as much area of our mask as possible. With our graph saved, let's apply it to our scene. Create 2 new materials, one for the acacia bark and one for the canopy, and set them both to use our custom shader. From there, it's just a simple matter of dragging and dropping our material textures into the corresponding slots. Now update the material inside your object prefabs. You should see the viewport refresh immediately. If for some reason the objects don't update, you can head back to the Terrains Tree or Details tab and reapply the prefabs. This forces Unity to reprocess the instances and clears any caching issues. While the ORM map being connected to the metallic output is technically correct, in our case it causes the object to look really glossy. So we'll remove the metallic connection in the shader and that should look way better now. I've also updated the other materials in the scene, so now they should also look correct. One thing we can notice is that the objects in the distance look somewhat off. This is because Unity switches to billboards from a certain distance. So to change this, we'll open up our landscape settings and go down there and change the tree distance, which controls how far trees are spawned, as well as the billboard start value, which controls the distance from where billboards are placed. With this set to a value of 250, this should look way better now. That concludes this simple introduction into the Unity bridge. If you have any further questions or run into any issues, let us know in the comments or join us in Discord. We can't wait to see what cool projects you build with it.